Here we have a historical problem. It says in 1304, Edward I built Warwolf, one of the largest catapults that's ever used in battle. Had a capacity to launch a 300-pound boulder, hence that's where the castles had such high walls, over 900 feet. The height of the projectile launched from Warwolf can be modeled by this function. Negative 16x squared plus 96x plus 40, where h of x represents the height of the projectile after x seconds. I want to graph the function. I want to interpret the key features of the graph in terms of these quantities. Now, you might have been asking yourself in the first couple, hey, can I just use Desmos? Well, none of the first two when I want you to understand the key features. But yeah, for the most part, you can use Desmos. You actually use Desmos on the first two to check your answer to make sure you're doing it right. But here's what we're going to do. We're going to graph this one. So I think I already put this in Desmos to save us some time. And negative 16x squared plus 96x plus 40, make sure you use y and x. The first thing you notice is, hey, that doesn't look like a parabola. It looks like two vertical lines, doesn't it? That's because if we look at here, it's at least starting 40 feet in the air. So I could either use my axis of symmetry formula, or I could just shrink it in until I can find that vertex. And notice it's up there as a way. So maybe what I want to do is I want to set my window so it'll be easier to see. So it says 3 and 184. So what I'm going to do here is I'm going to click on my wrench, and I'm going to go from like 0 to 10 seconds. 0 because it's real life and time can't be negative. And then I am terribly absent-minded, so 184. Okay, let's click on that wrench again. So I'm going to go from 0 to 10, and I'll go from 0 to 200. 201 that sounds about appropriate. Okay, there's my parabola. First thing I notice on my parabola is I want to find out where it crosses here. There you go. I want to find out where. Oh, there we go. Couldn't see that. I want to see where it crosses. Okay. It crosses about 6.4 seconds, isn't it? So that tells me the boulder is in the air for 6.4 seconds. Okay. So one of the key features, it's in the air for about 6.4 seconds. Which means it's going up for about I said 6.4, not for about 3.2 seconds. Then it's falling. Actually, I should take a look here. It's not actually 3.2, is it? Because it doesn't start at 0. Oh, yeah, 3.2 seconds. I was pretty close there. Okay, so it's going up for about 3 seconds is what it is. So we're going to say 3 seconds. It reaches a maximum height of about 184, we said. 184 feet. In other words, it'll clear a wall that's 184 feet provided you launched it at its maximum height. Okay? And notice it's not an easy one. In 1304, they didn't have a bunch of heavy equipment, so it starts 40 feet in the air. So the catapult starts 40 feet in the air. So they had to get that 300-pound boulder 40 feet in the air first. Then they're going to launch it. And when they launch it, it'll take about 6 seconds to hit its target, which to me is an awful long time for a weapon. Okay. And that's what we want to see. Tell me where it starts. Tell me the maximum height. Tell me how long it's in the air. That will be the key features of an application problem that we have there.